I want you to imagine, just for a moment, that you're sitting in the waiting area of a major, bustling city hospital.
Okay, I'm picturing it.
You can hear that steady hum of the machines, right? The paging system is calling out over the speakers. Doctors and nurses are rushing down the hallways with this intense focus. It's organized
A
chaos.
finely tuned machine.
Exactly. A machine keeping people alive.
Hmm.
But now I want you to imagine the lights flicker.
Oh, that's never good.
Just a brief blink. Maybe it's a power grid issue, or maybe a sophisticated cyber incident hits the local network. And suddenly, every single computer screen in the facility goes completely dark.
Just total black screen.
Total blackout, the hum stops. And in that terrifying silence, how do the doctors know what medications to administer to the critical patients in the ICU?
They don't.
Right. How does the emergency room admit the 3 ambulances pulling into the bay? Or how does the pharmacy know which prescriptions are actually safe to dispense without causing a fatal interaction?
It is a genuinely chilling scenario when you pause to visualize the sheer volume of data moving through those corridors every single second.
It really is.
I mean, we take the digital pulse of these environments completely for granted, right up until it stops beating.
Welcome to the deep dive. Our mission today is to unpack this invisible, vital digital safety net that keeps modern healthcare from collapsing into that exact terrifying scenario we just talked about.
Yeah, we are getting into the hidden world of cloud-native hospital management systems today.
We are. We're going to look specifically at how platforms like Medinous are architected to prevent these catastrophic failures. And we want to understand why infrastructure resilience has moved from, the IT basement to the C-suite.
Because it is quite literally the new heartbeat of patient care.
Exactly. And when I was looking at the architectural diagrams you sent over earlier for these cloud-native setups, I have to say they looked less like traditional IT schematics and more like sprawling, interconnected digital cityscapes.
I actually love that comparison. A sprawling digital cityscape represents the exact architectural shift we're exploring.
How so?
Well, we are moving far away from the days of isolated hardware troubleshooting. We're entering a world of enterprise-level operational survival. When a hospital's core network is distributed like a vast, multi-zoned city, it requires a completely different level of strategic thinking.
Right.
The modern hospital is a highly digitized, incredibly complex ecosystem, and the technology running it has to reflect that complexity.
So when we talk about a hospital management system or an HMS, today we aren't just talking about a glorified SQL database holding patient records, are we?
Not at all.
Because I think there's still this lingering perception out there that these systems are essentially just massive digital filing cabinets.
Yeah, that filing cabinet analogy is completely obsolete.
Okay.
Modern HMS is the central transactional layer of the entire healthcare organization. It is an active, breathing environment. It connects clinical care, diagnostics, pharmacy services, and the financial and billing operations into one unified fabric.
So everything is talking to everything else.
Exactly. Every single action, whether that's a clinical note, a diagnostic order for an MRI, a medication being dispensed, or even a patient being moved from triage to a surgical ward, all of that is captured, routed, and executed through this exact same environment. It is the central nervous system of the facility.
So if the network blinks, we are looking at a massive domino effect. You pull one thread and the whole fabric just unravels.
All of these critical workflows depend on synchronized, low-latency access to shared data. If the system goes down, and that can be due to a network failure, hardware outage, a cybersecurity incident, or even just routine infrastructure maintenance, the disruption does not stay contained in the IT department.
It spills over immediately.
Immediately.
Yeah.
The pharmacy cannot verify life-threatening drug interactions. The billing department cannot process discharges, which means new patients cannot get beds.
Wow.
And the clinical teams lose access to critical patient histories, allergies, and ongoing treatment plans.
So infrastructure resilience is no longer just an IT issue.
No, it is completely inseparable from operational and clinical resilience. You literally cannot separate the two anymore.
When a hospital's daily minute-by-minute workflow relies on shared data, the availability of that system dictates the continuity of patient care.
Exactly. If the system is down, care is compromised. It fundamentally changes how healthcare leadership has to view technology. Technology isn't just a tool the hospital uses anymore. It is the environment in which the hospital operates.
Let's look back for a second, because historically, hospitals really preferred having their servers on site. There was this prevailing perception that physical control over the hardware meant better security and better reliability. Like, if I can see the server, it's safe.
Right, the blinking lights in the basement.
Exactly. Why is that traditional on-premise model considered a trap today?
The on-premise trap creates a massive concentration of operational risk. Historically, yes, hospital software applications and databases operated on physical servers located inside the hospital facility itself.
In a dedicated server room.
Right. And this gave hospital IT teams physical control, sure, but it introduced severe structural limitations. You essentially create a single point of failure.
Because if something happens to that room,
If that one server room loses power or a pipe bursts or the cooling system fails and the machines overheat, everything stops. The entire hospital's digital heartbeat flatlines simply because it is dependent on the environmental stability of a single physical room.
and recovering from a physical hardware failure like that isn't a quick process. I mean, if a motherboard fries, you're waiting on supply chains.
You're waiting for parts, you're hoping the backups work. It's a nightmare.
But even beyond hardware failure, what happens during moments of extreme operational stress?
That is where the capacity constraints of on-premise infrastructure become truly dangerous. Say, patient volume spikes unexpectedly.
Like during a major local emergency or a mass casualty event?
Exactly. System usage skyrockets. The doctors and nurses are moving twice as fast, they're inputting twice as much data. Those physical servers have a hard limit on their computing power.
They can only process so much at once.
Right. And they can easily be overwhelmed and crash right at the exact moment the community needs the hospital the most. Furthermore, building redundancy in that physical environment is financially crippling.
Because you'd have to buy double of everything.
Smaller hospitals simply cannot afford to buy two of every multi-million-dollar server just to have a backup sitting idle in another room, just in case.
This brings us to the shift toward cloud-native architectures, and specifically platforms designed like Medinous. Now, you listening are likely well-versed in standard enterprise cloud migrations.
Sure, moving your company's email to the cloud.
Right, but taking a hospital's entire operational core to the cloud has to be infinitely more complex than migrating a corporate HR system.
It is an entirely different beast compared to standard enterprise software. Cloud-native healthcare architecture is not just taking a massive monolithic legacy application and sticking it on an external server.
So what makes it different?
Platforms like Medinous are architected from the ground up to operate natively within distributed cloud environments. They use a microservices approach.
Microservices. Break that down for us.
Instead of the HMS being one giant clunky program where everything is tangled together, it's designed as a collection of scalable, independent services.
Okay, but how does that modular approach actually benefit the hospital on, say, a random Tuesday afternoon?
It utilizes containerized application environments. Think about the old monolithic days. If the IT department needed to update the billing software, they often had to take the entire clinical system offline over the weekend.
And just pray it booted back up correctly on Monday morning.
Exactly.
All right.
But with containerization, a platform like Medinous can isolate these functions. So a hospital can deploy updates or fix a bug in the financial module seamlessly without ever interrupting the clinical charting module that the ER doctors are using at that exact moment.
That makes a lot of sense. But I have to ask, I hear the word cloud, and I immediately think of my personal Wi-Fi dropping during a critical video call.
Everyone does.
Right. So if a hospital moves its entire operational core to the cloud, aren't they just trading a physical server risk for an internet service provider risk? I mean, what happens if an excavator cuts a fiber optic cable down the street?
That is a very common concern. And it is why healthcare cloud architecture relies on dedicated redundant routing rather than standard commercial internet connections. But more importantly, cloud-native systems are built on the foundational principle of high availability.
High availability.
Yes, they operate across distributed computing environments. Your system isn't sitting in one basement anymore. Parts of it are running simultaneously in highly secure, compliant data centers that could be hundreds of miles apart.
So they're physically separated.
Yes, often in active configurations.
Meaning the system is constantly balancing the load between them.
Exactly. Think of the old on-premise system like a one-lane bridge. If a car breaks down in the middle of that bridge, traffic stops completely. Nobody's getting across until you move that car.
Right.
High availability architecture, like what Medinous utilizes, is engineered like a massive multi-lane superhighway. If a hardware failure occurs in one data center and blocks one lane, the automated system instantly detects it.
And it just routes around it.
Through advanced load balancing, it diverts all the system traffic to the other open lanes across different geographic availability zones. The users, the doctors and nurses looking at their screens, they barely even experience a lag. The flow never stops.
That automation has to drastically change the day-to-day lives of the hospital IT staff, too. They are no longer doing, digital janitorial work.
Monitoring server temperatures.
Right, managing localized hardware patches. They can actually focus on optimizing the software for the clinical teams.
It's a huge shift in resources.
But let's assume the worst for a second. High availability handles the hardware hiccups and the localized outages beautifully. What happens when a catastrophic event actually penetrates those defenses?
You mean a true disaster?
Yeah, a massive regional blackout, or a highly sophisticated ransomware attack that breaches the firewalls. What is the hospital's actual lifeline then?
When the preventative defenses fail, the conversation shifts from high availability to disaster recovery.
Okay, what's the difference?
High availability is about keeping the system running during a hiccup. Disaster recovery is about how you survive and restore when systems are fundamentally compromised.
Yeah.
In a healthcare environment, disaster recovery planning focuses relentlessly on protecting clinical data.
Because without the data, you can't treat the patients.
Exactly.
Yeah.
Platforms like Medinous handle this through deep, continuous database replication. They ensure patient data is synchronized across geographically separated zones, so an intact, clean copy always exists somewhere else.
Now, to measure how well a hospital is prepared for this, I know there are highly specific metrics that C-suite leaders and IT directors track. I like to think of these as the vital signs of the hospital's infrastructure.
That's a great way to put it. The baseline metric is system availability, which is just your raw uptime percentage. Are you up 99.9% of the time?
But the critical survival metrics are a bit different.
Yes, the survival metrics are RTO and RPO.
Let's start with RTO.
RTO stands for Recovery Time Objective. This defines the maximum acceptable amount of time required to restore system access following a major outage.
So it's a ticking clock.
A literal ticking clock.
Okay.
If the system goes completely dark, how long can the facility safely operate on paper protocols before patient safety is severely compromised?
And I imagine in a trauma center, that RTO window is incredibly short.
It's measured in minutes, not hours.
And then there is RPO, or Recovery Point Objective.
The RPO measures the data loss limit. It defines the maximum amount of data that could potentially be lost during a sudden system disruption.
Now, an RPO of near zero sounds ideal in a boardroom presentation. But what does a 5-minute data loss actually mean on the ICU floor?
This is where it gets very real. Think about a nurse administering a heavy, carefully titrated painkiller to a patient at 2 p.m.
Okay.
They log that administration into the HMS immediately. But at 2:01 p.m., a catastrophic system failure occurs.
Screens go dark.
Right. Now, if your hospital's RPO is 5 minutes, that means any data entered in the 5 minutes before the crash might not have backed up. That data from 2 p.m. is gone.
Oh, wow.
So when the next shift of nurses comes in and they look at the recovered system an hour later, it appears the patient hasn't received their medication yet.
Because the record of it was lost in that 5-minute window.
Exactly. So they might administer a second dose, leading to a fatal overdose. In healthcare, RPO isn't about losing a drafted email or a spreadsheet edit. It is a literal matter of life and death.
That puts an immense amount of pressure on the architecture to constantly, continuously replicate data. Every single second counts.
It does.
Beyond RTO and RPO, I know leaders also track infrastructure incident response time.
Yes. Incident response time measures how fast a threat or failure is detected, diagnosed, and neutralized.
But there's another metric you mentioned to me before, one that often gets overlooked but is absolutely crucial for the staff.
Data integrity and reconciliation efficiency.
Yes. What does reconciliation efficiency actually look like in practice for the staff on the ground?
Well, imagine the HMS goes down for 2 hours. During that time, the hospital doesn't stop.
People are still getting sick.
Right. Nurses are writing patient vitals on Post-it notes. They're using clipboards, whiteboards, whatever they have.
It's pure manual mode.
When the screens finally turn back on, reconciliation efficiency is how fast and how accurately the software helps the staff merge those manual paper notes back into the digital record.
Because you can't just type it all in as if it's happening right now.
Exactly. Does the system make it easy to backdate entries without throwing a bunch of compliance errors? Can it identify duplicate lab orders that were placed during the downtime?
If the reconciliation process is clunky, you end up with massive staff burnout.
Burnout and dangerous data fragmentation long after the IT outage is technically resolved. The IT team might say, we are back online, but the clinical staff is drowning in paperwork for the next 3 days.
So a truly resilient system like Medinous isn't just focused on staying online. It's actually engineered to help the human workforce gracefully recover when the unthinkable happens.
It supports the human element.
This completely reframes the conversation around hospital technology. We have moved way past the realm of the IT help desk resetting a password.
We are looking at a massive cultural and strategic shift at the highest levels of healthcare leadership. A decade ago, decisions about hospital IT infrastructure were treated purely as technical procurement discussions.
The board would allocate a budget and tell the IT department to just go buy some servers.
Make sure they fit in the basement. Yeah. But today, infrastructure architecture is an executive-level strategic imperative.
Because it dictates the bottom line just as much as it dictates patient outcomes. It dictates patient throughput, how fast clinical documentation happens, billing accuracy, and overall revenue cycle performance.
Infrastructure resilience is finally recognized as a fundamental component of enterprise operational risk management. When your clinical workflows depend entirely on digital platforms, your infrastructure architecture is your operational resilience strategy.
You can't have one without the other.
That is why leadership is seeking platforms specifically designed for this reality. Medinous represents this shift perfectly because it is built to support integrated clinical and operational workflows natively within these highly secure, distributed cloud environments.
It provides that high availability we talked about, that multi-lane highway, and it supports those strict RTO and RPO disaster recovery procedures.
It's the whole package.
Now, for you listening, I want you to take a second and think about your own workplace. Think about how complex your own workplace technology is. Think about how frustrating and disruptive it is when Slack goes down or your company's internal server crashes for an afternoon.
Productivity just grinds to a halt.
Completely. Teams can't communicate, meetings are canceled. Now take that frustration, multiply it by 1,000, and place it in a high-stakes, life-and-death hospital environment.
It's a completely different scale.
It puts into perspective exactly why platforms like Medinous and the shift to cloud-native distributed architecture are absolutely critical for modern operational survival.
It truly is the invisible digital safety net. By distributing infrastructure risk across resilient cloud environments, automating failovers, and rigorously protecting data integrity, hospitals can finally achieve the stability required to deliver uninterrupted care, regardless of the chaos happening outside or inside their walls.
The foundation of modern medicine is essentially invisible code running across distributed servers. So to wrap up our deep dive today, the core takeaways are clear. The era of the single point of failure in a hospital basement is over.
Long gone.
The operational risks are simply too high, and the capacity constraints are too dangerous. Modern healthcare continuity relies on the shift to distributed, cloud-native architectures like Medinous that utilize microservices and high availability.
And to ensure that patient care never skips a beat, hospitals must rigorously test and obsess over those metrics like recovery time objectives, recovery point objectives, and reconciliation efficiency.
The principles we've discussed today, high availability, strict recovery point objectives, distributed architecture, they make complex life-or-death hospital networks virtually uncrashable.
But, they also offer a really fascinating framework for looking at other complex systems.
Absolutely. If a hospital can engineer its systems to survive a total blackout without losing a single patient record, how might we apply this distributed resilience mindset to our own lives?
That's a great question.
Think about it. If you applied a strict RTO or RPO to your own personal digital data, or even to your career operations, how quickly could you bounce back from an unexpected total disruption?
Are you backing up your life's work?
Right. Are you operating like an old on-premise server with a single point of failure, or are you built like a resilient cloud-native system? It is definitely something to mull over. Thank you so much for joining us on this journey today. Keep questioning the world around you, keep looking for those invisible safety nets, and we will catch you on the next deep dive.